What does SD-WAN bring to the table? We'll take a look at that. I'll give you an overview of it in this class. Today, that's what my main objective is. But these are the things that we'll be covering in the class. You can if you want to, Victor, but most of the stuff is either on the screen over here, the PPT, or it is in the video as well. So because you're going to get the video, it's up to you if you want to take the notes or not. Most of the times I'll write it in Notepad and provide you the notes, but with this one, there's a lot of graphical stuff, and I created a PPT with the notes already, so I don't think you should need to. But if you do want to do it, go right ahead. I will share the PPT as well, yeah. So the overview of the class right now, the whole class, what are the different things that we'll be taking a look at? We'll be taking a look at what SD-WAN is all about, what's so good about SD-WAN, what makes it desirable as a technology. We'll take a look at that. It is something that I would highly recommend getting into. It is going to take over the wider network spectrum of what we're doing right now. So it is something that's a great thing that you guys are getting into it at this time. We'll take a look at the two type of devices that we have in the SD-WAN architecture. We have the controllers and we have the WAN edges. We'll take a look at how to initialize them from scratch. You've never worked with SD-WAN, absolutely no problem. I'm going to start you off from scratch. How do you build it up? But before that, what is it all about? We'll take a look at the power of SD-WAN through the use of templates. We'll take a look at the power of SD-WAN from the perspective of centralized policies. These are two main things that we'll take a look at. We'll also take a look at some advanced technologies or configurations. We'll take a look at T-lock extension. We'll take a look at direct internet access, a whole bunch of small little things that we'll also do once we have a good grasp of how SD-WAN is set up. All right. I don't think you need anything right now, Amit. I will give you I'll give you a full workbook that you go through. Plus, the videos would give you enough information to get started. So let's go ahead and take a look at what is SD-WAN all about. What does it allow us the ability to do? SD-WAN basically, first of all, is not something that you actually run with your service provider. SD-WAN is a technology that you run from your customer edge to the customer edge device. The role of the service provider over here is to provide your transport. So for example, let me bring up one of my topologies over here. If you take a look at it, SD-WAN as a technology is run between your site. So this is, let's say, your headquarters site. In the headquarters site, you have these controllers that I need to work with. And I need to work with these edges. These edges are called WAN edges. The WAN edges communicate to, on one side, one second. They communicate to the controllers for the purpose of management. That's a configuration bit of it. And control plane, which is the routing bit of it. But in terms of the data plane, that does not go to the controllers. That goes directly between the different edges. Now, as I said, the whole purpose of what? SD-WAN is not to work with the service providers. The service providers play an integral part, though. They're the ones that provide what is known as a transport. The transport in the form of MPLS, the transport in the form of the internet connections, and in some cases, you can also have transport in the form of a cellular network. Maybe as 5G, 4G, whatever your particular area has the capability of doing, you can also connect these sites using cellular. So all three, whether it's MPLS, whether it's internet, whether it's cellular, form the transport layer. This is also called the underlay network. All right. So the underlay network is the one that provides the connectivity between the SD WAN devices that you have. So as you guys can see, MPLS is in the transport layer. It is not in the SD WAN layer. Now, there is some element where you can say, okay, MPLS, some of the capabilities that MPLS provides, SD WAN can help you with that. That is true, and I'll explain that as we go through a detailed discussion about how MPLS plays into this part and how SD WAN can maybe lessen our reliance on MPLS, but there's certain places that you cannot do away with MPLS. And I'll explain that as we go through it. But I want you guys to be absolutely clear on a couple of things over here. Number one, that when we're talking about SD-WAN, we're talking about the overlay. The data network or your company network is SD-WAN. And you have two types of devices in SD-WAN, the WAN edges, basically your edge routers and your controllers. The controllers are the ones that provide the management and the control plane, the routing updates. The WAN edges among themselves are doing the data. They're responsible for passing the data. But the important element in the middle, as we talked about, is the transport. And the transport over here could be in the form of internet connections or even multiple internet connections. It's in the form of what? MPLS, or it can be in the form of cellular, just to give you some common popular examples of that. All good with this? You guys understand that, right? So this is the basic architecture that you have. You have controllers, you have the WAN edges, the actual data devices, and then you have the transport in the middle. Now, why SD-WAN? What does it do? How does it help us? The first thing it does is it moves us from a network that is reliant on per device configuration where you have the control plane. That is your routing protocols generally. Your management plane, where you have to go into each and every device and configure it separately. And the data plane and the responsibility of passing data, moving data across, all on the same device. So let's take a look at an example which MPLS will actually replace. That is a VPN, like a DMVPN type of setup. You have multiple edge devices that are connecting different sites to each other. Now, when you have something like that, these edge devices that you have, you need to log in separately using either Telnet or SSH and configure this device. That is the management plane. And I would need to do it separately on this guy, separately on this guy, separately on this guy. Once I'm done with that, then I run the routing protocol, EIGRP, OSPF, whatever you want to run, BGP as your protocol. You run it, and that allows you the ability to exchange routes with each other. Again, done on the same devices. So the same device I need to telnet into, same device I need to configure the routing protocol on into, and once the routing protocol is done, it is also then responsible taking care of propagating the data, passing the data across. So all these three things are done on the same device at this point without SD-WAN, or what a broader name for what I'm going to be talking about over here is SDN, software defined networks. So rather than doing it per device, where you actually manage each device separately, they want to get around that and use a technology or a mindset where everything is done from a centralized location in terms of what? The management of it, or even the control plane part of it, so, which is called controller-based networks. So in these type of networks, you don't go to each and every device and configure each device separately. You do it from a centralized management console. Controller-based network is not just for SD-WAN, it's for a broader type of setup called SDN, which includes Technologies like ACI, which is for the data center, and at the center of the ACI mechanism is your APIC. This is meant for your data center management, internal data center management. Similarly, you have SD WAN, which we're going to talk about over here. Over here, the main device that manages it is vManage. But vManage with SD WAN, what they've done is they've also broken down some other aspects of it, like the control plane, which is done by a device known as the vSmart. And there's also another device called vBond, and I'll explain that to you guys what the functionality of this is. We did that in the overview, but I'll go in more detail over here with the vBond characteristics. And similar type of network, this is for your wide area network, as the name suggests. And the third thing is the SD access, which again, you guys are going to see later on in the course, which is done through a device, again, a controller device called GNAC, with the help of the ICE device. So these are your centralized management devices that are there. How does it work? Let's now focus on SD-WAN in terms of this. This is a broader picture of where SD-WAN fits. Now, in terms of SD-WAN, in terms of the controller-based systems, how does it work? You have three separate devices, as I explained to you guys, vManage, vSmart, and vBond, that are responsible for the management of it. So you don't need to go and do management on each and every device. What you do is you configure a device known as vManage. You do all the configuration over here, and you push the configuration, the interface configuration, the name of the device, the protocol you're going to run. The actual configuration is done on vManage and is pushed down to these WAN edges. The WAN edges are the ones that are actually responsible for moving the data, pushing the data across. So on these WAN edges, the configuration is not going to be done from where? From the local device. It is going to be done from where? This vManage device. The good thing about that is that it is template based. So if you have multiple devices that have similar type of characteristics, you don't need to do it over and over again. It is centrally based on templates. So you can create a single template and push it down to multiple devices. And once you see what I can do with it as I go through the demonstrations for that, you will fall in love with it. It's all graphical now. Although you do have the ability to do it from the command line, very limiting in terms of what you can do on the command line. Most of the stuff is done from the graphical perspective. Although it does have a command line, at the end of the day, when it pushes the config through the graphical, it actually goes into your, like a running config, and you can see the actual config over there. There are built-in templates over there. Yes, you have the ability to edit them, or you can create your own. You can copy the built-in templates and then make your own as well. There's a lot of different things that you can do with it. How are the devices behind the site routers managed? Okay, we'll take a look at that later on. I'm just talking about the edges over there. Absolutely, you have the ability now because you have a central device that you have the ability to manage it from. So if you want to do any programmability to it, you want to do automation with it, there's APIs that are available that you have the ability to automate stuff over here by writing an API, but you don't need to write the API for everything else. It is done for what? You just need to do it for the API would only be required to do it on the vManage, and because it's a centralized controller, it can push that configuration to all the WAN devices. So there's APIs for programmability as well over there. The REST API is the one, the most commonly used one. vManage is highly resilient. What if this guy is not available? Well, guess what? You need to get two guys, right? Single point of failure, single guy will have issues. But at least you don't have to have 100 guys. Let's say I have 100 sites. You don't need to have 100 guys. You can have a smaller number of devices. Okay, we're specifically looking at what? The SD-WAN devices. The other devices, if you want to manage centrally, you have other network management software for that. That's also your answer the answer to your question in regards to what do you do with the devices behind it. You guys, let's keep these non-technical stuff like job security and all that type of stuff for later on. Let's focus on the actual technology part of it. It's in a cluster. If you have two vManages, it's in a cluster. You don't need to actually, you shouldn't keep it in one location. You should spread it across. So it's not like a secondary vManage. You basically can cluster it. So it's fully redundant. So that depends. I don't know the data sheet of it, but you can have more than 2 in a cluster. 2 would be a pair. All right, guys. So you have vManage over here. You have the edges over here. So the programmability, I'll get to that. Programmability is going to be done to the vManage. vManage is responsible in terms of the control-based system for just your WAN edges. I'm not using vManage to manage your voice traffic or voice devices or routers or switches. It is not prime. You get my point. It is more specific to managing your SD WAN type of characteristics or SD WAN type of devices. So it's a controller for that. You understand that? It is not going to take over your entire network. I'm not talking about Prime over here, which uses SNMP as a centralized management device. It is specifically to manage your SD WAN implementation. You get my point, guys? So inside site routers, voice routers, other devices, you need to have other management software for that. I'm focusing on how we can centrally manage your wide area network. Now, so that's what SD-WAN does. That's what vManage does in terms of SD-WAN. It's a controller-based system where you do all the configuration on vManage using templates and push it down to all the WAN devices. So let's say a new device comes up. All you got to do is push the template to the device and the device is ready to go. Within minutes, you can get a site up and running. Good so far, guys? Everybody okay with the vManage aspect of it? So it's a configuration device. Now, the next device over here, which is for the purpose of control plane, is another controller, and they wanted to split up the different planes that you have, or this management plane, control plane, or data plane into different devices. So they put the responsibility of routing to a separate controller called vSmart. vSmart is another controller that is in your SD-WAN fabric. Its responsibility, the only responsibility it has, actually it has a couple. It is basically for managing your control plane. So all your routing that takes place. And routing is not done by your routing protocols that you guys are aware of. It is no OSPF, no EIGRP, no BGP. It runs its own protocol for the management of the control plane management of these devices. That protocol is called the Overlay Management Protocol, OMP. All right? It runs a protocol called OMP that exchanges routes, the internal routes that are behind the WAN edges with vSmart, but the WAN edges don't talk to each other. All of them talk to one through the vSmart. You don't want to have one. You can have multiple vSmarts for redundancy. But for right now, just keep it simple. We'll talk about resiliency and redundancy later on. Just focus on the technology at this point. So you have vSmart, all the different WAN edges will establish a relationship with the vSmart. They will send their routes, their internal routes over here. Let's say these are 3 sites, 172.16, let's say 1.0 as an example, 172.16, 2.0, 172.16, 3.0. All these routes will be propagated to vSmart using OMP, and OMP in turn, it will act as a route reflector that you have in BGP, and it reflects the route to the WAN edges. So now he's going to learn the routes. His relationship, his control plane is only with the vSmart. He does not establish a relationship with the other WAN edges. All the routes are learned through vSmart. So over here, when I learn a route, I will learn the route 172.16.20 and 172.16.30. The actual control plane is from the vSmart, but at the same time, just like a route reflector does not change the next hop, for this WAN edge, let's call it A, B, and C, for simplicity's sake right now, he will get the route with the next hop being B. He'll get this next hop as C. So in terms of the data traffic, by default, it is going to use the local transport that it has over here. It will use a local transport to communicate directly with the other WAN edges. Can we see the routes? Absolutely. There's a command, show IP route, show MP routes, bunch of different commands we'll take a look at in terms of technicality, how to see the routes. Absolutely, you can see the routes on your WAN edges. But again, when you see those routes, what is the next stop going to be? Is it going to be the vSmart? No, it's not going to be the vSmart. It is going to be the other WAN edges over here. Whether it's B or C or A, it's going to be pointing towards the devices. The vSmart never participates in the data plane. There you go. I just basically what you said is what I said. It does not participate in the data plane. Its responsibility is strictly for what? It's for the control plane. So if they've completely segregated control plane from the data plane. All right. So although you're getting the route from vSmart, in your configuration over here, you won't see any pointer over here towards the vSmart. You guys good with this so far? You guys understand that? So the control plane is completely different. Any need to fully understand how OMP works? The stuff that you need, I'll show you over there. Again, in terms of, no, you will lose the route. To be honest with you, the reason you lose the route is what? Actually, take that back. There's a certain timer that it keeps. You will still have the data plane. You're right. It will still keep the data plane. So there is tunnels between edges like DMVPN. Absolutely, we'll talk about that as well. As I said, it goes directly between each other. I'll explain that as we go through it. And we'll get to that. Let me get there. It was done by Viptela. Yes, now Cisco owns it. What will be the next stop? The next stop will be B or C. It will never be vSmart. As I said, vSmart is never in the data plane, so it cannot be the next stop ever. You get my point, guys. Everybody okay with that? It's not hub and spoke. Hub and spoke in DMVPN, Ahmed, means that the data traffic goes from the hub. Yeah? Is any data going through the hub? It's more like a RR, as Tom said, if you had to compare it to something. All right. And what was the other question? So vSmart is just like RR. That is correct. That is correct. So it does not go into the data plane at all. Now, the other thing, Hunter, I want to point out over here is that in the RR, because you have the ability of the transport to go through the RR, not because of the control plane, but because of the IGP, the traffic can still go through the RR to get to the other side, even with VPN v4. Here, there's no choice. You understand that? You get that, Hunter? Because over there, the transport can be tuned that the IGP is also using the vSmart, sorry, the RR to go through it. Here, you don't have a choice. vSmart will never be in the data plane. Now, what is the difference between vSmart and vManage? vManage is just your configuration part of it. It does not play any part in control plane or data plane. So when you do the configuration, you'll push the configuration to A, B, and C. You will also push the configuration to vSmart. But vManage will not establish any OMP tunnels, or that is for the control plane, or for that matter, data tunnels between the edge devices. It's just used for the purpose of doing what? The configuration part of it. Did you get that? It's just for the configuration. Think about this in a very crude manner, being telnet. So you're sitting on your admin device and doing telnet. So vManage does have tunnels towards the V edges, absolutely, for the configuration bit of it, yes. It's a vManage is the construction, vSmart is the actual, well, it's the actual workhorse. It's the one that's actually doing the work. That is correct. vManage is just, if you lose vManage, what happens? You won't be able to make any new changes to it. vManage does not use OMP because OMP is used between the vSmart and the WAN edges. Although you configure the vManage to tell A, B, and C to run OMP or configure different parameters for OMP. You get my point? ARP has nothing to do with this over here. What if I'm running a serial link over here? Do I need ARP for that? That's layer 2, right? Between configuration changes, George, not changes in terms of, see, there's a difference between you configuring router OSPF1 and putting the network statements. Those changes will go from vSmart to vManage, but the actual routes that are learned because of that configuration will not go across. Do vManage and vSmart connect through OMP? As I said, no. I answered that question already. Now, the tunnels between vManage and vEdges, I'll talk about those as we go through it. This is good enough for right now. We'll take a look at other things as we go through it. At an overview level, what I want you guys to understand at this point is the functionality of vManage, the functionality of vSmart. Everybody okay with that? At an overview level, you guys are okay with it? Details, we'll go through it as we do it. Now, the third device, that is something that is different than the other devices, is used only at the start point. It's more of an security guard for your network. So we talked about vManage being part of what? The configuration plane or the management plane, vSmart being the control plane. The third device is called vBond. vBond is your authenticator. What do I mean by the authenticator? When a WAN edge comes up and it needs to communicate to your SD WAN architecture, the only device that has been configured over here on the WAN edge is the IP address of your vBond. The WAN edge has no idea about vManage or vSmart IP addresses. It goes and registers to vBond. There is mutual authentication that takes place over here. The WAN edge says, I want to join your SD-WAN setup, and he sends him a certificate. It's certificate-based authentication. I'll go in and explain how these certificates work in a bit. Absolutely. All of these things, there's no, what do you call it? How should I say it? No optional things over here. If there's anything optional, I'll let you know. So as soon as the WAN edge comes up, the only device it is aware of at this point is the IP address of what? vBond. So when it comes up, it goes to the vBond, says, I want to join your setup. Could you please tell me if you're the correct vBond or not? So he's going to send his certificate over here. I am the vBond for this particular company. There's mutual authentication done based on what are known as certificates. So the WAN edge will go into and register to vBond, authenticate it. vBond will authenticate the WAN edge. If that authentication is successful, based on the successful authentication, the vBond orchestrates the thing. He basically tells him, hey, listen, good, you authenticated. The IP address of your vManage and vSmart is, and gives the IP address of these devices. And vBond in the background also lets vManage and vSmart know, hey, listen, this WAN edge is an authenticated device. Let him in. So basically, he's the one that makes this relationship possible by letting vManage and vSmart know of this authenticated WAN edge and letting WAN edge know that these are the two devices that you need to communicate to. We will go through that, Antonio. Understand it at the overview level. The actual configuration bit of it, I'll explain that to you. As I said, you need to configure the IP address of the VBON on this device. So the first communication in this place will always happen between the WAN edge to the VBON. You get my point? This communication between WAN edge and the VBON is through DTLS. Correct. You have an option of TLS, but most of the time you're going to use the communication mechanism of DTLS to authenticate this. This tunnel that is set up, this is a secure tunnel, which is set up between your WAN edge and your VBON. This is a DTLS tunnel. It doesn't stay up though. Once the authentication takes place, this tunnel goes down. Then the WAN edge establishes two permanent tunnels with whom? With the WAN, the vManage as well as the vStart. Every time the vEdge wants to come in, it will need to authenticate with the VBON. So the initial part, because when it goes down, it'll break the WAN, the DTLS tunnels to reestablish it. It needs to go through the same process again. Absolutely. Remember OMP? So I need to exchange the routes. So that is done all done through DTLS. So it has two permanent tunnels, one with the vManage, one with the vSmart. Good so far, you guys? Now, do you understand the rules? Don't worry about the configuration bit of it. I'll show it to you one step at a time. But what I want you guys to get out at this particular moment is the functionality of what a vManage does, a vSmart, and VBON. OMP is a control plane that is only run between the vSmart and the vEdges. That is correct, Wilson. All right. So the only thing this is done, this is doing what? Authentication. This one is only doing what? Management. This one is responsible for the control plane. Keep alive between vEdge and vManage to keep the tunnel up. Yeah, it's done through BFD. That is correct. If the VBON is down, you will not be able to authenticate the new devices. So DTLS for VBON and OMP for vManage. So DTLS for VBON. No. OMP is, again, what is the purpose of OMP? You guys are missing, I think you're moving around or something. The only place that OMP works is where? Between the vSmart and the edges. That's it. That's OMP. Understand the purpose. OMP is a control protocol, right? So the control protocol is between the vSmart and the WAN edges. Got it? The tunnels that are set up for management purposes to make sure this communication is secure is all DTLS. And OMP, it will also be a DTLS tunnel between these guys for exchanging the route. So OMP will run on top of your DTLS tunnel. Authentication between vEdges and VBON will happen only once or periodically. Authentication with vEdges, no, every time it comes up. I think I've answered that question already. When, 3 people have asked that question. What protocol vSmart, vManage, vSmart, VBON communicate with each other? Depends on what they're doing. Generally, it is netconf because it's a configuration part that the vManage is doing. If VBON fails offline after the device is authenticated, will the device remain up? Absolutely, because the authentication is done. Does all the underlay devices end-to-end need to support OMP? No, they don't. Why? What is the underlay doing? So that's a good question. So I'm communicating between the edges. What is the underlay doing over here? The purpose of underlay is to allow IP communication between what? between your vSmart or vManage or vBond to whom? So this is your transport to your WAN edges. So all the underlay is doing is providing reachability, IP reachability between what? These devices. You guys understand that? So when the packet comes in, when this guy wants to reach the WAN edge or the WAN edge wants to reach vBond, it needs to have IP reachability.